is now being recorded. Okay, so welcome again to this webinar on the production of tailor-made fertilizers from biorefinery. This afternoon, we will go a little bit more into this topic. Before I give the floor to Kari Ylivainio, I would like to say a few words about the ESNI community. This webinar is organized by the Working Group on Agronomic Performance, which is one of the 4 working groups that we have within the ESNI community. And the ESNI community being itself a part of the Biorefine Cluster Europe. So as you can see on the slide, there are 4 working groups. We have a working group on technologies. We have a working group on agronomic performance of fertilizing products. We have a working group on sustainability assessment. And then finally, we have a working group on policies and everything that is related to the pathway to market these circular fertilizers. So as you probably have understood, ESNI is about nutrient recovery and nutrient recycling. This is a very specific topic that is a part of the biorefine cluster itself. Before I give the floor to Kari, I would just like to mention the fact that after the first part, we will have an interactive session with Q&A. And to start this Q&A session, we will have 3 questions that we will present to you by using Slido. And it is a very easy to use tool online. I will give you a few words of explanation when we start these questions, so that we have a good understanding of what your questions or concerns are when you participate in this webinar. At the same time, you will be able to ask questions in the chat, but I will repeat it again after the first part. So I will now shortly introduce Kari Ylivainio, who is a principal scientist at the National Resources Institute, Finland. He has a Master of Science in Agricultural Chemistry and Physics, and he holds a PhD in Environmental Soil Science, both from the University of Helsinki. His career has focused on plant nutrition and related processes in soils, particularly optimizing phosphorus fertilization using bio-based fertilizer produced from various nutrient-rich side streams, as well as minimizing potential nutrient losses. Kari has coordinated Lex4Bio, which was a Horizon 2020 project aimed at optimizing the use of bio-based fertilizers in crop production while minimizing environmental risk, ensuring food and feed safety and supply, and protecting human health. So Kari is the proud chairman of our working group on agronomic performance, and I would like to give the floor now to Kari.
Thank you, Hans, for this nice introduction. And now I'm honored to introduce our keynote speaker, Oskar Schoumans. He works as a senior scientist at Wageningen University and Research in the field of nutrient management and environmental impact for almost 40 years. He has a strong international network and has coordinated a large number of national and international programs and projects related to Nitrate Directive, Water Framework Directive, and Circular Economy and Farm to Fork. The last 10 years, his research mainly focuses on closing agricultural nutrient cycles, valorization of organic waste and manure surpluses, and the agronomic and environmental impact. He coordinated the European Innovation Project Systemic, where industries and SMEs implement and demonstrate innovative systems of nutrient recovery techniques on large-scale biogas plant, and he is a leader of work related to the production of tailor-made fertilizers of the European FERTIMANURE project, which has just been finalized. In both projects, the latest techniques of the valorization of organic waste into valuable agricultural fertilizers are demonstrated and evaluated. And now Oskar will present a tool that was produced in FERTIMANURE project, and the title is Production of Tailor-Made Fertilizers from Biorefinery. So Oskar, floor is yours.
Okay, Kari, thank you very much for this nice introduction. I will share my screen now. And put it in PowerPoint. So, if correct, you can see the full screen now of my PowerPoint presentation. Yes, my name is...
looking good.
Yeah, okay, thank you very much. Oskar Schoumans, and I will present now the tailor-made fertilization tool that was developed within the work of FERTIMANURE during the last 4 years. First of all, I will start with the definition of bio-based fertilizer, because that is the product made from different innovative nutrient recovery technologies. So bio-based fertilizers are fertilizing products or components to be used in production of tailor-made fertilizers that are derived from biomass-related resources. And within the BBFs of FERTIMANURE are obtained through a physical, thermal chemical or biological processes for the treatment of manure or digestate that result into a change in composition due to a change in concentration of nutrients and their ratios compared to the input materials in order to get better marketable products, providing farmers with nutrients of sufficient quality. So it is the treatment of manure or digested manure into new products. We have stated that just separation of manure in a solid and liquid fraction as first processing step in many applications of processing manure, that is included. These products are not conceived as a BBF, although they are valuable sources to supply nutrients at agricultural land. So there is really a need of a physical, chemical or biological change of the input material into a BBF. What becomes a tailor-made fertilizer? What's our definition within that project of FERTIMANURE? A tailor-made fertilizer is a customized fertilizer that meets with the nutrient requirements of a specific crop by taking into account the soil type, soil fertility status, and the growing conditions and fertilization practices. So the TMF obtained in FERTIMANURE are produced from BBF, so produced from manure in digestate or recovered fertilizing products that are available, and mineral fertilizers, and we includes also biostimulants. First remark to make over here that fully crop-specific tailor-made fertilizers can be defined as centralized produced, assuming a sufficient nutrient status of the soil and no additions of fertilization practice. So that is a centralized approach where a company tried to make TMFs just based on BBFs and manure and mineral fertilizer components. However, if you are going to work on farm level, The soil crop requirements will be different due to another nutrient status of the soil and the fact that often manure digestate will be applied on the fields, which has to be taken into account as nutrient supplier. So then the tailor-made fertilizer, the composition of that will be different because there is already manure available. So a tailor-made fertilizer depends on the local circumstances that you want to apply the nutrients to crop requirements. So we decided to build a nutrition tool, a soil crop nutrition tool, which calculates the tailor-made fertilizer composition based on BBFs or manure fractions or whatsoever. So the aim of the tool is to calculate the optimal combination of the amounts of available sources, that can be mineral fertilizer, BBFs and or manure fractions, in order to meet with the nutrient requirements of a specific soil crop combination, and by taking into account the soil fertility status and or the prices of the fertilizer products. And if needed, legal restrictions should be considered. In some countries, in nitrate vulnerable zones, for instance, there are limits for the amount of manure that can be applied. Furthermore, what was decided, the tool has to be simple, transparent, easy to access, and open source so that everybody can work with it. And we decided to build it into Excel, an Excel-based and download approach, and it can be downloaded from the website. So this is what should be made, a TMF tool that minimize the difference in requirements and costs of using different types of input products. There we have manure, bio-based fertilizers, and mineral fertilizers. And within the FERTIMANURE project, we collect all the data from pilots with nutrient recovery and user entry options regarding the quality of manure, for instance, and the mineral fertilizers. Second input is, of course, the data from nations, the crop soil needs, which can differ from nation to nation, and also the legal restrictions. So there are limits to the amount that can be applied. And furthermore, the pricing that can be based on a nutrient of interest approach or the CAPEX OPEX approach of the real business cases of the innovative nutrient recovery plans. So these are the three most important inputs of the tool in order to calculate the optimal combination of sources for a soil crop combination. You will get blending warnings, the carbon storage is estimated, and also the gaseous and emissions to the air. And in the end, it should be user friendly. I will showcase now the main input screens of the tool and explain how it works. But first of all, these are the 18 BBFs and final composition of the 5 demonstration plants in Spain, the Netherlands. I will show the pointer. In the Netherlands, Germany, Belgium, and France, and they produced after their technology different products, which we called the BBFs. So nutrient-rich concentrates, biodried solid fractions, phosphorus acids, ammonium salts, etc., etc. So different products were produced at those sites. And you can see here what is still assumed to be manure and has to deal with the nitrate vulnerable zones and legal amounts of manure that can be applied in those nitrate vulnerable zones. Those products over here are not assumed to be manure anymore, so more or less another fertilizer, but not manure anymore. And especially the ammonium phosphide, perlite, ammonium nitrate, sulfate, and ammonium water are in that way recovered that they are comparable with the renewer definition of non-manure, and which means they become a mineral fertilizer. Here the nitrogen fertilizer replacement value is given of those products and the amount of organic matter, total N, phosphorus, potassium and sulfur. So those information is as a table in the tool and can be used for selection of BBFs. Also, we defined for the nutrient requirements for 44 crop soil combinations from Spain, France, Belgium, Netherlands again, with the amount of nitrogen, phosphate, kali and sulfur that is required. So there is already a long list of different type of crops and a huge variation in amounts of nutrient requirements. So also already in the tool, and you can enlarge it by yourself. Here are the legal restrictions for all the soil crop types in different countries in terms of manure, effective nitrogen and phosphate, based on the nitrate directive amount of nitrogen that can be applied to the soil. So also the restrictions are already in the tool. Also, besides the BBFs, we also need the composition and prices of mineral fertilizers, and we used in this approach the single nutrient mineral fertilizers, calcium ammonium nitrate, triple superphosphate, potent kali and glycerite for nitrogen, phosphorus, potassium and sulfur. And also we used for organic matter for compost, and here you can see the amounts available in those nutrients and the milk market prices. These are the prices from last year, but you can update them yourself in the Excel tool and calculate the new price per kilogram of nitrogen, phosphate, potassium, sulfur and effective organic matter. So these values are used for each kilogram of nutrients. There is strong fluctuation over time, but currently the levels are back again on the level of 2021. So these are the real minerals, and for organic matter, as said, compost is used with an amount bulk market price of 20 euros per ton. If we are going to look into the bio-based fertilizers, then you first can calculate, based on the pricing of N and the content of nitrogen in the bio-based fertilizer, what the value is of nitrogen, phosphate in that product. So this is the nutrient-rich concentrate, for instance. there is still some kali in it and has its price, sulfur and effective organic matter. So total valuable price, intrinsic value of about 17 euro. And for each of the 18 products, this has been calculated in for every BBF. And if you have a new BBF, you can do the same based on the prices of each of kilogram of nitrogen and your content in the BBF. Calculate your own price, your value of that product. If we want to substitute mineral fertilizers, then you do it often for just one nutrient. So the nutrient-rich concentrate, it is done for nitrogen. So this price has been used as substitution price for mineral fertilizers. Here, organic matter, P ashes. Over here, the price of P is used as the price of that product in the calculation of the optimization procedure. So that is based on the most important utilization nutrient. So the nutrient of interest is mentioned over here, and the price related in that product is used in the tool. Biostimulants, they highly react on bioavailability of nutrients. Nitrogen often used as most active response, but in fact the prices can be much higher in the market. But we didn't find any approach to calculate it for biostimulants, so we have used nitrogen in that case. And biochar and organic soil conditions are better related to the price of ton of carbon or effective organic matter than the prices of mineral fertilizer. So there we used organic matter, which was derived from the value of compost. So pricing as issues were set for all BBFs. We have the prices also for the mineral fertilizers. And we also figured out for each of the pilot plant, the production, the CAPEX, OPEX prices of the different type of products, which are in most cases higher than the prices based on the nutrient of interest, because there are demonstration pilots not really efficient yet, not optimized in all conditions, so that's why the prices are higher. But it can be selected if you want to do the prices on the nutrient of interest or based on the CAPEX OPEX approach. Then the optimization will be different. So coming back to this part, we collected all the data, manure, BBFs, mineral fertilizers. We collected information of the crop and soil needs, so the requirements in M, P, K and S, and if there are legal restrictions. And we have the prices based on the nutrient of interest approach, the value of the products itself, and the CAPEX, OPEX approach. How expensive is it to produce those products? So the outcome is an optimal combination of sources, blending warmings, carbon storage, and gaseous emissions, and I will focus now on that part also. First of all, this is the input screen of the Excel-based tool, where you first has to select which type of BBFs you want to use into your optimization procedure. So you can select the country of the pilot plants with produce defined BBFs, or you can define your own BBF and their composition. So you get an input screen, you can put for your own BBF the data that you want to use. The second point is you have to select the country with legislation and the crop requirements. For instance, here grassland is selected. The soil information can be set if it is sufficient or low or high. Are the limits for phosphate, and do you take also the limit for S into account for sulfur? So then you have the selection of the crop requirements and the soil conditions just by drop down, or you can define your own crop requirements and condition. Then you get a screen where you can fill in the relevant information for that crop. Finally, there is a focus on the manure. You can use standard data, Dutch data for the composition of different type of manures, or you can select one of the pilot plants where the exact manure quality was filled in. Or also in this case, you can fill in your own manure quality via an input screen, the similar one as used over here for the BBF. Then you select manure. And finally, you have to say the optimization, is it based on the price of the nutrient of interest plus the recommendations of the crop, or just the recommendation and don't take into account the nutrient of interest prices, but just focus on the recommendation of the crop, the requirements of the crop. So quite simple left side approach with selection options. So first select the BBFs that you want to take into account. Select the crop requirements, and if there are legislative issues over there, select the available type of manure, and then select the conditions for optimization of the composition of the tailor-made fertilizers based on the BBFs, based on the mineral fertilizer composition and manure if needed. This is the right screen of the Excel. The second part going in order to the steps to find the optimal solution. The first step is you can set everything to 0. That means the BBFs, no BBFs and no manure. That will calculate the exact combination of mineral fertilizers to be applied to meet with the crop requirements. Then in the second step, you can set the BBFs only, or set only the manure. Then it will be optimized only for the manure, or you can set BBFs and manure together and in order to find the optimal combination. If needed, the third step, you could say 1 or 2 or 3 of the sources to be used is fixed. For instance, if you want to apply at least 5 tons of pig slurry, then you can fix that amount and it is not changed in the optimization routine. And the last button that you have to press then, and that is optimize, and it will be calculate the optimum combination of the amount of manure, bio-based fertilizers and mineral fertilizers. So step 1, only mineral fertilizers are selected. Step 2, include BBFs or manures or both. Some amounts of sources can be set as fixed, and then the optimization is made. You also see some buttons for doing multiple runs. That is only reported for reporting issues, because we have 5 pilot plants, 44 soil crop combination, 5 approaches to be used in mineral fertilizers or BBFs and mineral fertilizers and different types of manures, and 2 optimization procedures with and without pricing. So in total, 2,200 combinations are possible based on the input. So we made buttons to run all those inputs after each other. But for you, it's not. If you want to test it and use it, this is just sufficient to optimize your situation. Okay, let's do an example. Here, maize on a loamy soil is selected. You can see here the recommendation. Maximum amount is of manure nitrogen is 170, so it is in a nitrate vulnerable zone. You are not applied more of nitrogen in terms of manure. The total amount can be higher, of course, because mineral fertilizers can be additionally added. Then the amount of P that is required for the crop, potassium, sulfur, and you want to have also an amount of organic matter, for instance, 4,000 kilograms per hectare. If I select only the mineral fertilizers, so the first step, then you can see here what you need as calcium ammonium nitrate. This is the amount in ton per hectare. In order to meet exactly with the amount of mineral fertilizers, triple superphosphate, 90 kilograms, and then you apply 70.5, which is required for maize on loamy sands, similar for kali and for kieserite. The amounts are calculated. And based on the prices of those products per ton, it's calculated times the amount that you need, what the total price is of the minerals that are required over here. So that is 607, that's given as answer. It will cost you about 600 euro per hectare to apply those type of mineral fertilizers. But in this case, there are only mineral fertilizers and no addition of organic matter. There it is, the 0. So that's a pity. This is green because you don't apply manure at all. You are in nitrate vulnerable zone, so it's 0. That is really great. No manure at all. So it's really becomes green over here. And here the values are quite okay. So you get a red color in case that you are too high, and you get a green color that you are too low. Here you see the sign that applied should be always less than 170. This is optimized, should be equal, and the amount of phosphate should be should be higher than the recommendations. Also for kali and sulfur, they should be at least higher than the amount needed for the crop. So this is the simple outcome, looking at what is needed, the recommendation and what has been applied by the mineral fertilizers and what the costs are. If I say, for instance, the next one, we will include bio-based fertilizers. 5 types were included, but the answer given in this case that only 2 have to be optimized. That's the nutrient-rich concentrate and the bio-dried solid fraction that were selected. And you can see that much less of mineral fertilizers have to be applied and the costs are less. And that this amount is applied in terms of nutrient-rich concentrate with this price, and you need 30, so this is nutrient of interest price, 30 ton, so 150, it will cost you about 150 euro. And 3 tons of bio-dried solid fraction, it will cost you about, this is the price per ton, and it will cost you about 233 euro. It's optimized. You are below the maximum amount of nitrogen over here as manure. And total is 210. So this amount of S over here, this amount of mineral N over here, and calcium ammonium nitrate. There is a little bit too much phosphate applied by this combination, but it is okay. It should be higher than at least this. The amount of potassium is just equal to each other, and also sulfate is okay, just in equilibrium. The price is a little bit higher, 75 euro higher, but in this case, you don't apply 0 organic matter, but half of what is optimum yet. So there is an advantage, a little bit higher price, but an advantage that you apply organic matter to the soil and reduce the amount of mineral fertilizers. Now the last option is include also manure. In that case, solid fraction of pig slurry has to be used. Still the nutrient-rich concentrate in a different amount, bio-dried solid fraction, and less mineral fertilizers has to be applied. And here you can see that everything is still okay. Requirements, we are below the amount of nitrogen in manure. Mineral N is okay, 210 required, 210 applied. Phosphate a little bit higher. Potassium okay. S total okay. And a little bit less over here, but the prices are now below the amount of mineral fertilizers, and still you apply an amount of organic matter to the soil. So this as first example. What you can do if you want to increase, for example, the amount of organic matter, you can increase this value of 1 to about 100 or a value of thousands. Then in the optimization routine, he tries to figure it out that it becomes really 4,000, but then the prices will become higher probably. So once again, the TMF input screen, left side, you do the selections. What do you want to take into account as BBFs, as crop, soil crop, and manure types, and how do you want to set the optimization procedure. And in the right side, you can select only mineral fertilizers, or do you want to include BBFs or both BBFs or only manure, different combinations you can select. And then just push the button optimize. After application and filling in, you get blending warnings. Code used for defining certain risks. Because if you are going to blend certain products with each other, can be safety risks. For instance, there can be a risk of precipitation, the risks of toxic gas formation, and things like that. So we use codes for that, and we check if there are if it is allowed or if it is not allowed over there. For instance, by using different type of products in the bio-based fertilizers over here, it's reported in the report that there can be issues if you combine it with other products. For instance, emissions to the air or whatsoever. So you have to take care of blending such type of products. It can be done, but you have to take care of the possible risks. A simple figure can be produced at your output screen if you hit that button. That shows directly the situation that you use only mineral fertilizers. In this case, for grassland in the Netherlands, you see that in total it's okay. There is no box over here. Also for P total, for potassium, okay, for sulfur, okay, but the price is about €700. But you don't get about 4,000 of kilograms of organic matter. So it's times 10 kilogram organic matter per hectare. So that's your missing value. And if you have a certain TMF tested, then you get directly the outcome as a figure. For instance, N total is okay, P total is okay. There's a little difference over surplus in potassium. S total is too high, probably because ammonium sulfate has been used, and a little bit organic matter is too low, but the price drops down in this case from €700 to about €250. So you directly see here it is optimum, but everything is okay regarding your minerals, but the price is high and no organic matter. And here the situation where you give a little bit too much in terms of potassium and sulfate, and a little bit too less in organic matter, but the price is much lower. Just one figure to explain what the advantage is of the tailor-made fertilizer compared to using mineral fertilizers itself. Here you can see it if you do a multiple runs, and it's a sheet in the Excel tool that generates itself. For instance, maize on a loamy soil. You see here two figures. This is the first figure and the second figure. This is when you use the price and the recommendations as optimization, and here you do use only the recommendations, so the requirements of the crop and not the pricing. Here you see what is used in terms of mineral fertilizers. So here only mineral fertilizers are used. Here only BBFs and mineral fertilizers. and here a certain amount of manure can be applied, the blue also. And you can see what will happen. The price on the right side, it will drop down. Here, mineral fertilizer, in this case, it will be lower if you use only mineral fertilizers and BBFs. And then it further drops down if you are going to use different manure types, which are presented over here. This is price included, including the recommendation options, and here just if you don't include the prices of all the products, then you get this price line. You also get, for those situations, directly how much organic matter is applied. In this case, nothing, because you use mineral fertilizers, no organic matter, and you see here the difference in organic matter. If you, this case, it was 2000 required, and you can see if you reach it. Here for P, it's okay with the mineral fertilizers, but for the different approaches, you are a little bit too high. And here also for sulfur, it's shown, and you can see that probably ammonium sulfate in this case is used. So you apply too much sulfate to the soil, more than recommended. So as general outcome of multiple runs, we included also the carbon storage in the soil using the Rotsey approach. So you get also a figure for the same for the price and recommendation approach. So the requirements, and the other one just on the recommendations, how much organic matter is left after 1 year in the soil and after 30 years. So that is the red one. So in those situations, you can estimate what will what your carbon storage will be after 30 years. Furthermore, it's shown what the emissions are. We, for the different products, we have included the emission factors over here, tier 1 of the IPPC approach. So if we know the amount that is applied, pig slurry, ammonium sulfate, a nutrient-rich soil, for instance, then it is calculated the amount of organic matter after 30 years, but also the amount of emissions to the air caused by different products. So also that environmental risk is included in the tool, and you get the total N emissions based for that combination of manure and BBF, so the TMF that you have defined. So coming to the end, input is available. The tool, we calculate the optimum combination of sources. There are blending warnings for the risk if you are going to combine the products together. There is a calculation of the carbon storage, and the gaseous emissions are calculated. It's in a user-friendly Excel-based tool that can be downloaded, and you can change the data for yourself. So coming to the conclusions, a TMF approach has been developed. A TMF crop soil nutrition tool has been developed to optimize the application of manure fraction, BBFs, and synthetic mineral fertilizers. And optional, the costs will be included in order to meet with the crop requirements, both N phosphorus, potassium, sulfur, and organic matter, and it can take into account legal restrictions. The tool is Excel-based, transparent, and made fully user-friendly. The tool has been enhanced with carbon storage in the soil and nitrogen emissions to the air. And the developed approach is helpful to define which products, both BBFs and mineral fertilizers and manure, should be utilized in a specific field, soil crop combination, and you can use it also for a regional based approach where you look at the different soil crop combinations and look which manure fraction has to be built together with the bio-based fertilizers and the mineral fertilizers. There is one main deliverable from the report, deliverable to 3.7. That's the product specification and practical criteria to produce TMFs. That means with the nutrients requirements, and it describes completely the whole tool. And we made a description of the modules and macros of the Excel tool, so you can go into detail into the tool to look at it, into the macros and change it yourself. It's open source. Yeah, there is no time anymore, but if you want, I can show directly in the Excel tool how it works, but that maybe later on. So for now, thank you very much for your time, and I do hope that you are going to use this tool to calculate the tailor-made fertilizer based on mineral fertilizers, the BBFs that you produce, and the amount of manure that you have access to. Thank you very much.
Yes, thank you, Dr. Schoumans, for this detailed explanation of this tool. Just for clarification to the participants, I suppose this tool is downloadable from the FERTIMANURE project website. Is that correct?
Yeah, that's correct, but it's not still there. I don't know why it was submitted, but they have probably some troubles with uploading all the final deliverables. There are more deliverables, updating the final deliverables on the website, but it will be available over there. And if people want to have it earlier already, they can send me an email and I send it directly to them.
Okay, thank you for your clarification on that. So after this detailed explanation by Dr. Schoumans, we now have scheduled some time to have an open discussion on the fertilizing products. And to start this open discussion, we have prepared 3 questions. And we would like to present you now these 3 questions as a way to understand a little bit the situation that you are in as a participant to this webinar. So it will help us to understand a little bit what is your current background and maybe requirements and questions that you have on the use of circular fertilizers. So these questions are quite generic, and the first one is now presented on your screen. There are 2 options to join the session. As you can see on the left-hand side, you can scan the QR code with your smartphone, and then you are immediately directed to the question, and then you just simply click yes or no, or you open browser, go to slido.com, where you can then enter the number of the survey, and it follows the same logic. You just click yes or no on this question. This first question is your project focusing on optimizing fertilization? As we understand that a lot of participants are within a research project on optimization of fertilization. So this is a little bit to understand what you are working on within your project. So we will keep this going a few more moments before we then go to the next question. And I am sure that Kari is following this very closely to see a little bit what the results are, so that he can then also, for the discussion, take this into account.
Yes, it
Okay,
seems that at the moment, majority is dealing with these issues, so that's great.
Yeah, that's good. Okay, I think we can go to the second question now. So the same logic. Join the survey through the two methods, and the next question is about is the optimization focusing on regional, on national, or on continental scale? So again, we wait just a few more moments to make sure that everybody has the opportunity to give an answer to that. Still some answers coming in. So do not hesitate to join the survey. We currently have 12 people who have replied, and we have around 26 people in the webinar. So I would like to call upon your willingness to open the survey and give an answer. That would be nice.
I suppose this tells something that, of course, manure is the main nutrient-rich side streams, and of course, it's a, let's say, if it's a problem, it's in many cases a local issue. How to deal with these excess manures, for example. So, but it's good that even at the continental scale, there's a project working on this issue.
Okay.
Yeah.
So I think we can close this question now. So Kari already gave your feedback. So third and final question: what is the biggest challenge for optimizing fertilization in your opinion? And this is an open question. So you can fill in a keyword or a few words. And then this will appear on the screen as a word cloud, so that we have a general impression of the challenges that you are facing, or that you see as a challenge for the optimization of fertilization. I think in this case, Kari, we can then maybe try to identify if there are some trends here that we can discuss, but that's depending also on the type of responses that we get.
Very good responses, yes. Okay, I think that this will give us a base for discussions. So I now open this discussion. So if you have a question or comment, you can just raise your hand or write it on a chat, so we will raise that up. I can start the discussion. Thanks for the very nice presentation. This is indeed a very good tool for the farmers, and I think that for the advisors and policymakers as well, to evaluate how these different kind of TMFs can be used for replacing mineral fertilizers. So this is based on a FERTIMANURE project. So have you got any feedback from the farmers? What do they think about this tool? Have they used it? I suppose this is quite new tool, so has there been any chance to get some comments from the farmers about this?
Not yet, Kari, because it wasn't available and they didn't test it yet, but it was tested by a group of experts, scientific experts, and they made a lot of additions that they want to include it for mainly related to carbon storage and related to the emissions to the air, so the contamination aspects, because it works. They found it okay to do the optimization of which BBFs and manure has to be combined in order to meet with the crop requirements. So from that point it was okay. They only want to add more and more and more in order to see what will be the negative impact regarding emissions to the air, to groundwater and surface water. We stopped over there because it will become rather complex for farmers, and it needs to be quite easy and transparent. So just looking at the main sources that are available, the mineral fertilizer at first, and the manure that the farmer has, and then the information of the BBFs. It was already quite a lot of information for them to understand in the whole optimization procedure, but they, most of them liked it very much.
Yeah. And it's interesting that you showed also this economic, because I suppose that's one of the biggest issues related to, let's say, better uptake of these tailor-made fertilizers.
Yeah.
As a manure is the, let's say, main source of these BBFs. So you started with separation of solid and liquid fraction. When you got the liquid fraction and then solid, what technologies did you use here in this separation? So what was the efficiency? Well, commonly liquid fraction contains the nitrogen part of the manure, and then solid fraction of contains phosphorus. So did you manage to reach good efficiency? Because I suppose this will have an effect on the quality of BBFs as well later on.
Okay, what we used as input in this modeling approach were the 5 pilot plants in the countries. So they have their own treatment approach, starting with manure or digested manure and then doing the separation in their own way. It can be screw press or centrifuge or whatsoever. And then they got the solid and the liquid fraction. That was put into the tool as composition, just as it was. And indeed, depending on the separation technology, you will get different composition. But a user is able to add his own composition if he wants to. And there are also tables with standard values from literature. The composition of different type of manures are in the tool, including the different type of separation technologies. So if you choose centrifuge or you choose screw press or belt press, then it calculates, the tool will calculate the solid and the liquid fraction and use that as manure input for the optimization procedure. So there are also theoretical options put in the tool for the optimization procedure.
Yes. Okay. Because commonly in manure, this nitrogen phosphorus ratio is not optimal for crop production. And like you showed, many of these TMFs produce, let's say, more phosphorus than required by the crop. So is it difficult to, let's say, obtain an optimal N and P ratio on these tailor-made fertilizers? Because I suppose in some regions where you have soils are very saturated with phosphorus, you shouldn't apply, let's say, no phosphorus at all, so mainly nitrogen. So this separation phase is very important one for producing these fertilizers.
Yeah, that is possible. You just have to say the requirements of the crop, and if it is for phosphorus because of the high content in the soil, for instance 0, then it will try to find out a combination where the amount of phosphorus is as low as possible. Most of the time you will have to, you will apply some phosphorus, but you can the optimization procedure will reduce it to 0 if the costs are still acceptable. So then for instance a very good separated liquid fraction will be used with a low phosphate content and no pHs, no solid fractions. In that case, a real mineral N fertilizer like ammonium nitrate or ammonium sulfate, which were produced by the pilot plants, will be used in that case.
Okay. I suppose there is not any questions yet, so I can then continue. When you calculated these costs per hectare, they were mainly based on these nutrient prices. But from the farmer's point of view, if you had to select many different types of TMFs, so the farmer would also need then, let's say, different kind of equipment for spreading these different types of fertilizers. If you are spreading mineral fertilizers, and then you would have like a liquid fraction of manure and then some other tailor-made fertilizers. So is this considered in this tool?
It's the application itself is not considered in this tool because every products need its own price for spreading. However,
Yes.
that's why we focus also on the blending. Most of the products can be blended together. And in that case, you just apply it at once to the field. That will reduce the cost of different type of applications. In France, they developed, for instance, within FERTIMANURE, an approach for combining mineral fertilizers, manure, and BBFs in order to meet with the crop requirements. If you do it in a certain way, then the risks of the blending risk are limited, and then you only need one application in order to meet with the crop requirements. For grassland, however, you need more than one application during the year, but also in that case, you can adjust it for S, potassium, nitrogen by blending the right components with each other.
Okay. So is there companies, for example, in Netherlands that would produce these TMFs at the moment, or what's the current situation?
The current situation is that more and more farmers are going to combine the different type of fertilizers with manure, especially the renewal products are often combined with the manure products before they are applied to the land. In fact, it's not allowed because they have their own nutrient fertilizer replacement value, and if you combine them, then it will be different. But in practice, it's being done just to reduce the cost of application.
Yes. Hans, you have raised your hand. You're muted.
Sorry for that. Yes, I noticed there are a few questions were asked on the chat, and maybe we could go into those questions while we have Dr. Schoumans still here. I think there are some quite some interesting questions there. So the first one is, can you see them, Kari? The questions coming in? I can read them out loud if you want. So
yes,
there was somebody
from Ronald.
Yes.
Okay, I can read the question. Ronald, thanks for the very interesting presentation, which it was indeed. And the question is, for biostimulants, could we consider including phosphorus alongside nitrogen in the budget calculations? Companies like Tuubi Organics already market human urine-based biostimulants that reduce phosphorus needs by 50%. A comprehensive list of microorganisms and their associated nutrients might be valuable, especially with potential regulatory updates. So this was the first question. So if we go one by one, then.
Yeah.
So the biostimulants.
Yeah.
So are they? Yeah.
That's a difficult one. I already said in my presentation, what's the price of a biostimulant and how does it work in practice? There are often a lot of ideas about the effectiveness, but there are limited tests about the effectiveness. But still, if you say that that using the biostimulant you need less phosphate, then it is quite simple in the tool. Then you reduce the P requirements of that crop with 50%, and then the optimization will find out which products has to be used, and you can set the biostimulant as fixed. That's why we include the fixed amount in the soil. Sometimes a farmer want to use 5 ton of pig slurry, or somebody else want to use 100 kilograms of a biostimulant. Then you can fix it. It's not changed in the optimization. It's always given that amount. So by reducing the amount of phosphorus, the required amount of phosphorus, you can easily say that biostimulants will be applied. Then you can easily calculate the new optimum of bio-based fertilizer, mineral fertilizers, and manure to optimize the crop requirements. So that's in principle not a problem.
Okay, thanks. The second question is, how are contaminants like heavy metals and biohazards being evaluated in the various streams?
Yeah. Okay. It is an soil crop nutrition tool. So in the first place, have focused on the nitrogen, phosphate, kali, sulfate, and organic matter, not on the impact of heavy metals. However, from all components, all the sources in the tool, we also have and it's included the content of the heavy metals in the products, but it is not presented as result. But you as user, if you know the amount that has to be applied for different components, you can exactly calculate the amount of heavy metals that will be applied. But it's not the focus of the tool. That's on nutrients and the recommendations. And there are no real recommendations for heavy metals.
Does the tool consider like fertilizing products regulations, because there's a limits for heavy metals? So,
Yeah.
but I suppose there wasn't a box where you can tick the content or concentration of heavy metals.
No, it's not included in that way.
Yes. Okay, the next question is, for regions using transgenic crops like USA, China, potentially Europe, how do you account for potentially different nutrient requirements? Is there actually existing any, I suppose there isn't any, let's say, own recommendation for GMOs, or do you know?
We didn't include them. So what we did is we checked only for 5 countries in the FERTIMANURE project what the limits and recommendations were, and we didn't extend that for other circumstances. But the end users who want to include it can easily include those conditions in the tool. So you can extend the list with TMOs and then run for those circumstances the tool. But we didn't do it for USA, China, or Eastern Europe or whatsoever. Only the data that we got at this moment. It's more or less an example. Make it user-friendly. It was not the intention to make it worldwide applicable.
Yeah, exactly. Okay, then the next question from Hiba Segrud. Sorry if I pronounced the name wrong. Many thanks for your interesting presentation. I have one question. If you have an idea, how can the production of tailor-made biofertilizers from microalgae-based biorefineries be optimized to improve nutrient release efficiency?
Yeah, that's that's not dealing with the tool itself. I think it's just more a general question in how the production of tailor-made from microalgae based can be optimized. In all cases, you need to define the quality of the BBFs. If it is based on which, doesn't matter which sources you are processing, always you need to calculate or define the quality of the product. The really impact of, for instance, on the roots or the efficiency of uptake is not part of the whole routine at all.
I was considering that in your tool, is it, for example, nitrogen use efficiency? Is it considered as 100%, or is there different, like for manure 70%, or is it considered 100%?
No, it's not 100%. It fluctuates from 10% to 100%, depending on the BBF itself. So it's 100% for ammonium nitrate, ammonium sulfate, and ammonia water and things like that. But for solid fractions, it can be 50% or 30%. And even in biochar, it will be 10% because it doesn't. So that's included because you may apply more if the nutrient use efficiency is lower. The fertilizer replacement value is lower of a certain product. You can apply more because it won't be available in the first year. So that's why we included for each product the nitrogen fertilizer replacement value. And also if you are going to use for algae, then you have to say what the nitrogen fertilizer replacement value is in order to include it in the tool.
Okay. In that case, if you have these organic BBFs or tailor-made fertilizers, are you then considering these residual fertilization values? So, of course, it will. If you are applying year after year these organic fertilizers, you are increasing organic carbon stock in soil.
Yeah.
In principle, but is this taken into account?
Yeah, that's taken into account. You will see it in the carbon storage, because if you use, for instance, bio-dried organic material, whatever, with a low nitrogen fertilizer replacement value, then you will see much more accumulation in the soil than if you use the liquid fraction of pig slurry, for instance. That's taken into account, and you will see what the impact will be on your soil carbon. Yeah, the lower the nitrogen fertilizer replacement value, the higher the carbon storage in the soil will be.
Yeah, but is this nitrogen content, this nitrogen residual fertilization value also considered the same way as its carbon stock? So of course there will be, at some point you will reach equilibrium where the mineralization is at a constant level, I suppose.
Yeah, I fully agree with you, but the application of the recommendation in many countries take into account just the first year of the amount of nutrients that will become available. In other countries, they directly only look at the total amount, and that's much better if you don't want to have real accumulation in the soil of your nutrients, especially phosphate, things like that. That's why I think using the nitrogen fertilization value is not a good approach in many countries, where they, because they will apply too much nitrogen to the soil and the leaching will increase.
Yeah, I totally agree with you.
Yeah.
I think that we have a question on a chat. Muhammad Karl, hello, I'm Muhammad from Beta Juvik. Many thanks for your valuable presentation. On slide 21, for the calculation of nitrogen units, have you considered also nitrogen included in organic matter added as compost, for example, added as a carbon source, and how it could be calculated? This is...
Yeah, both are taken into account. The composition of compost itself is not used as BBF or organic material or manure or whatsoever. I used compost in order to calculate the value of organic matter. The price for compost is different from country to country, but we said compost, it's 20 euro per ton. So in that case, I can set based on the composition of compost, I can calculate what a kilogram of organic matter, what the prices of a kilogram of organic matter is, of effective organic matter. And I use that to set the price of organic products of the BBF, so the biodried and the biochar. There is still an amount of organic matter, and then you can calculate the value of organic matter over there. So compost itself wasn't used as product in the optimization procedure, but used to set the pricing of organic rich products.
Okay, thank you. The next question concerns about biochar. So I suppose you can specify the nutrient content of biochar, pH, and a feedstock. So can this be modified in a tool, or is there, let's say, one figures for biochar, or can those be modified?
It can be modified. There are some biochars in the listing already. In France, it was produced, and in Germany, it was produced. They have their own specific composition, but you can add in your tool your own biochar with its specific composition, and then you can select it. So that is, it can be, the list can be extended.
One interesting point with these organic fertilizers is also that, of course, the mineralization rate varies depending on soil type. So can these mineralization rates also accommodated in a tool? For example, in Southern Europe, where you have calcareous soils, the mineralization rate is much faster compared to, let's say, in Scandinavian countries.
Yeah, it is. It can be, because the rate depends on the temperature, and you can set a different temperature in the tool for your own region, and that will calculate higher or lower rates for the breakdown of the three fractions of the Rotsey tool. So they are conditioned under 20 degrees, so include over there, but if you are working at 25 degrees or 10 degrees, then it can be changed by changing the temperature of your situation in your country that you select. Yeah.
Yes, exactly. So, of course, you are now retired, but
almost.
almost still working. But is there a plan to, let's say, further modify this tool? And if so, what would you think that would be next step in order to improve the take-up of these tailor-made fertilizers? What would be the most important things?
Yeah, I hope when it has been uploaded to the FERTIMANURE site, and maybe you should contact Laia about this, then everybody is going to use it, and there will be coming more questions, and can we adapt this, and can we approve it? That's why we made a description of all the macros into the Excel and how it can be used, and a complete description. So people can do it by themselves, but if there are question raised again that needs to be included in the tool, which they can't do by themselves, then we have to see in the project what we can do to implement it and to improve it, because within the FERTIMANURE it's finalized. There is no budget over there, but there are possibilities, of course, to improve the tool if it is really used in such a way that it meets with the real requirements of the stakeholders. If they are the farmers or maybe advisors who coming to the farm, if they want to improve it, then I will be there to help to improve it. Yeah.
Mm-hmm. Yeah, I can see that, for example, from the environmental point of view, I think, for example, like a carbon footprint would be a good idea to include here. But of course, that would take a lot of extra work to include that into the tool.
Yeah, what you can do is calculate in at least we already calculate the carbon storage in the soil. So what you applied is the rest is going to the air. So that CO2 footprint can be easily added to the tool. It will be much more difficult to implement for different pilot plants how their CO2 footprint is, because that depends from pilot plant to pilot plant. How you look at CO2 footprint, what do you take into account? That will make much more complex. The main focus is we don't want to over-fertilize the soil. We want to give as much as needed for the crops. And if you do that in the right way, then the losses will be minimized. Then the losses will be less. If the nutrient use efficiency is high, then the losses will be low. That is the starting point of the whole tool. And you can enlarge it, extend it with different aspects: heavy metals, nitrate leaching, nutrient losses to the surface water, ammonia emissions, etc., etc. You can make it as complex as you want, but I still think that you should focus on what is the optimal conditions, circumstances on a field scale. That's where it happens. There you want to have the lowest emissions as possible.
Yes. And when considering the, let's say, nutrient translocation in Europe, so there are regions with plenty of nitrogen and phosphorus in these different types of side streams, including Belgium and Netherlands, compared to eastern part of Europe. So in order to transfer these nutrients, let's say, across Europe, we definitely need quite efficient technologies in order to produce these tailor-made fertilizers. And for that, of course, we need to increase the concentration of nutrients in order to reduce the transportation costs.
Yeah.
So yes. And I think that the carbon issue here is quite relevant. So do you think that the biochar would be a relevant source if we forget the price of producing biochar? So according to your tool, in a long term, could we increase soil carbon stock if we use biochar as a soil amendment? Of course, it's more like a soil amendment than a fertilizer.
Yeah. Then you have to look at it in a certain moment. If you look after 30 years, there will be accumulation in the soil. But if you look after 100 years, then the product, if you do add it once, then the product will be probably completely gone at all and taken over in the whole humus biomass of the soil itself. All products will become in the end turned over, but it is about the time scale that you are looking at, and we have set a time scale of 30 years to say, okay, then you can say it's accumulation, but after 100 years the figures will be different, of course.
Definitely, yes. Still considering this tool, for example, with nitrogen fertilization, so can you also change the application method? I suppose in many places in Southern Europe, broadcasting is one of the most common application methods. Whereas if you incorporate the fertilizer in soil, you will drastically reduce ammonia losses.
Yeah.
So I didn't notice that there wasn't this kind of a box to click the method of application.
No, we didn't include it. It was just to in the first place to calculate the optimum blend of manure, bio-based fertilizers and mineral fertilizers. That was the first place, and not the application method, because that has to be developed based on for certain crops and things like that. And the environmental aspects dealing with the application methods are not included. It stops by making an optimum product for the soil crop requirements, and then it stops.
Yes, exactly. Well, is there any question from the audience? Now is a good chance to ask about this tool. We have an expert online. I suppose there's no questions on chat. Hans?
Yes, I have just only one question, and we already touched upon it briefly. It's not purely on the scientific side of the tool, but more on the uptake. So if I understood well, so this tool will become available, and but as the project has finished, there will be no actions or initiatives to promote the use of the tool, if I understand well, which I think is a bit a pity, unless there are other things planned as part of other initiatives, maybe. Because if the tool is just available on the website, I'm not sure if a lot of people will use it, which I think would be a pity. But yeah, that's a little bit of concern. Let me put it that way.
No, I can understand that. I think there will be a final leaflet or whatsoever by FERTIMANURE sent around to the and the newsletter and things like that.
Yeah,
that it is available and with the final deliverables, etc., etc. And I think also in new running projects, European projects, it should be taken into account that this model is available, so it can be used. And again, yeah.
Thank you.
Elena, you have raised your hand.
Yes, hello. I am Elena from Slovak University of Agriculture, and currently we are first year in the project Nenufar, which is involving, it's more about nutrient recycling, and our university is trying to reuse nitrogen and phosphorus from dairy wastewater using algae, and the output of the project for our demo site will be bio-based fertilizer. So if you can share the tool, we will be happy to apply it for our demo case. And also there are some other countries involved. The difference is that the other demo sites work with different type of biofertilizers. So if you search for some users, we can volunteer.
Yeah,
and also,
okay.
I am involved in the field experiment with biochar, and as I catch the talk about the biochar, and we ran the experiment for 10 years now. Actually, it's the 11th year field experiment. It's very unique regarding Slovakia scale, and it is not really easy to maintain the running experiment for so long. But I wanted to say that we still can find it there, even if we applied it only once. In 2014, it's when we do sampling, like nearly every month we do sampling, it still can be found. But we also have some plots with reapplication. So of course, it's much easier to see there. But even the one time application, single application, 10 years ago, it's still enough.
Yeah. Okay. Okay. I'm willing to help in using this this tool, and the best way forward is if it is used in many European projects itself, and yeah, I can help over there. That's no problem. Yeah.
So if you maybe I can write you email and you can share the tool, because we are only first year in our Horizon project, but for the deliverables, they are still not uploaded, none of them yet. So it's like 1 year. So probably for your tool, you know, the software, it's, yeah, it would be pity if we can use it right now.
Yeah. Okay.
Thank you very much.
Yeah, you're welcome.
Any other comments or questions to Oskar? Okay, if there's no more. Hans?
No, I did not see any other questions, so I think maybe it is time that we can wrap up this session, unless you have other topics that you would like to share, Kari.
No, I think that I did all my questions already, so, and I think we got a very nice overview of this tool. So let's hope that many of it will try and to see how it works in your own soil conditions and growing conditions. So I definitely try that one. Of course, I think that, for example, here in Finland, we have tools, but they are mainly dedicated for application of mineral fertilizers. So I haven't seen this kind of a tool that are meant for organic fertilizer, bio-based fertilizers. So this is a very good addition to our toolbox. And of course, this is the way that in a circular economy that we should try to use these or recycle nutrients as efficiently as possible. So this is a very excellent tool for that one.
I agree.
I suppose we can go forward. Do you,
yes.
Hans, have a slides? We are a little bit, we are still 10 minutes, but we can wrap up
I think,
a few minutes earlier.
I think we can wrap up the webinar. So first of all, I would like to thank you, Dr. Schoumans, for your contribution to this webinar. I think it was very interesting to hear your explanation on this tool. And so on behalf of the ESNI community, thank you for that. Thank you for Kari for reaching out to Dr. Schoumans. His network was very relevant for that. We do have more webinars coming up from the ESNI community, so it is relevant to check out our website from the BioRefine cluster, where there is a dedicated page on the ESNI community, also from the other working groups. So I would suggest people to make sure that they check the web page. It is mentioned, as you can see, at the right-hand side at the bottom. If you have any other questions or need more information, you can either contact Kari for the work group on agronomic performance. If you want to reach out to the BioRefine Cluster Europe or the ESNI community in general, you can send an email to the email that is mentioned now on the screen. So unless there are any other questions, I think we can call it a day. And I would like to thank everyone for their participation. And we hope to see you again in a next webinar without question, another interesting topic for ESNI. Thank you very much.
And I think that there was some information of the upcoming webinars. Was there on this?
Yes, well, actually, there are webinars upcoming in March on technologies. However, the dates have not been confirmed yet, so they're close to confirmation. But we will communicate them separately to all the people through the bulletin and through our social media accounts. But these are scheduled in March. But as we didn't have the confirmation on the dates, we have waited for that. Okay.
Yep. Okay, and I want to thank also all of you for joining this webinar, and especially Dr. Schoumans for giving us this excellent presentation. Thank you.
You're welcome. Okay. Bye-bye.
Yeah.
Thank you very much.
Bye-bye.
Bye-bye.
Bye.